Hello friends, have you ever wondered why a bowl always falls downward? Why a magnet attracts iron towards itself? Or why the sun shines in the sky? The answer to all these whys can be found in just one place, physics. Today, we will understand the foundation of this subject. Physics is not just a subject in your textbook, it is the language spoken by the entire universe. The smartphone in your hand, the electricity in your homes, and the GPS that guides your car, all of these work because someone understood and applied the fundamental laws of the physics. Whether you are a school student learning physics for the first time or an aspirant preparing for exams like JEE NEET, understanding these nine core branches will become your most powerful starting point. So let's decode these nine branches with the real world context. The first branch is mechanics. Physics begins from here. In this branch, we study motion, force, and energy, and it is completely based on Newton's three laws of motion. Whether it is calculating the trajectory of a cricket ball or designing a car suspension, mechanics is everywhere. The most famous and important equation of this branch is F is equals to m into A. It is one of the most elegant statements in physics that binds force, mass, and acceleration into a perfect mathematical relationship. The second branch is thermodynamics. It tells us what is physically possible in this universe and what is not. This branch explains why no engine in the world can ever be 100% efficient or work perfectly. From the refrigerator in your home to jet engines in airplanes and even weather systems and the human body, thermodynamics works everywhere. It introduces the concept of entropy, which shows that universe always moves towards disorder or chaos, one of the most profound ideas in science. The third branch is electromagnetism. It combines electricity and magnetism, two separate forces into a single framework. It is explained through Maxwell's equation. Ohm's law V equals to IR, which is used in everyday circuit of your home, is a part of this branch. Every electric motor, generator, radio signal, and even the speed of light comes from electromagnetic theory. The fourth branch is optics, which is the physics of light and vision. It helps us understand reflection, refraction, and the behavior of lenses. It also introduces wave optics, where interference and diffraction prove the wave nature of light. Whether it is the glasses we wear, smartphone cameras, fiber optics cables that provide fast internet, or advanced laser surgery, all of these exist because we mastered optics. The fifth branch is modern physics. At the beginning of 20th century, two revolutionary ideas changed the rules of classical physics forever. Einstein's theory of relativity and quantum mechanics. Relativity taught us that space and time are flexible and the mass and energy can be interchanged, expressed by the formula E equals to m into c square. Meanwhile, quantum mechanics showed that the particles behave in a very strange way at the atomic level. These ideas gave birth to nuclear energy, semiconductors, lasers, and MRI machines. The sixth branch is waves and sound. The most special property of a wave is that it transfers energy from one place to another without moving matter itself. Sound waves are longitudinal and require a medium to travel, whereas electromagnetic waves like light can travel even in a vacuum without any medium. The change in the sound of an ambulance siren as it approaches is called the Doppler effect, and the medical ultrasound is also an application of this branch. Seventh branch is oscillations. Continuous motion back and forth around a central position called equilibrium is known as oscillation. Its most fundamental form is simple harmonic motion, which is described by Hooke's law, F is equals to negative K into X. From pendulums to vibrating guitar strings and resonance in large structures, all of these are the part of oscillations. The eighth branch is electronics. It combines quantum physics and electromagnetism to control electric current inside semiconductor devices. The invention of transistor in 1947 brought a digital revolution to the world. Today, billions of transistors can fit into a single silicon chip, powering your phones and computers. Logic gates perform Boolean operations, which form the basic foundation of all digital components. The ninth branch is astrophysics. It applies physics on the large scale to stars, galaxies, black holes, and the entire universe. This branch searches for answers to major questions like a Big Bang and the source of energy in stars. The Hubble telescope and gravitational wave detectors have opened new doors to the cosmos for us. But do you know? About 95% of the universe is made of dark matter and dark energy, which still remains among the greatest open mysteries in science. Now, the most important point: no branch of physics works in isolation. All of them are deeply connected, and it is because of this interconnection that our modern world functions. For example, the GPS in your phone is not just a single system. For those satellites to function correctly, they require both orbital mechanics and Einstein's relativity corrections working together. Similarly, building and operating a medical MRI machine requires the combined use of nuclear physics, electromagnetism, and wave theory. And today's electronics is essentially applied quantum mechanics. A very common question is, what is the difference between classical and modern physics? It's simple. Classical physics, such as mechanics and thermodynamics, works for everyday objects at normal speeds. But when the speed becomes extremely high, gravity becomes very strong, or we deal with atoms where classical rules break down, we need the support of modern physics. If you are just starting physics, always begin with mechanics. It clears everyday concepts like force, motion, and energy and gives you the confidence and mathematical foundation needed to study the other branches. And for the students preparing for competitive exams like JEE and NEET, building a strong grip on these 9 branches is extremely crucial. These fundamentals are the core components of your exams, and mastering them can help you score highly with ease. So, the conclusion is, friends, the universe follows certain rules, and physics teaches us what those rules are. From a falling branch to the electrons inside a computer chip, everything happening in this world reveals a deeper layer of physics. If you enjoyed learning about these 9 branches of physics, the manual of the universe, then like the video right now, share it with your friends and classmates, and don't forget to subscribe to the channel and press the bell icon. For more in-depth learning, you can visit physicsfundamentals.in. See you in the next video. Keep learning.